All right, problems numbers 5 and 6 on the first assignment 27A. This is the electricity, windmills generating electricity in the wind. They give you a little computer printout and ask you to find line of best fit. So remember, I know it's hard to see here, but slope 0.24, y-intercept 0.137. So electricity is equal to 0.24 times the wind plus the 0.137. If you use E or W, you got to tell them what you're referring to when you use it. It says identify all the variables, so just how to use those. Then it says how much more electricity would you expect to produce if the wind velocity is 25 versus when it's 15. I just plug them in, right? 25, I plugged in 25, got 6.137, plugged in 15, got 3.7, subtracted them, 2.4 amperes more. Part C says, what proportion of the variation in electricity is explained by the relationship with wind velocity? So that specifically is just r squared. That is the definition of r squared. The percent of y, that can be explained by the percent of x. So 87.3%, r squared was given right here, 87.3%. And they said, is there evidence that electricity production is related to wind velocity? So, so just a slope test, basically. The null hypothesis is the slope is equal to 0, no relationship, no linear relationship, I guess I should say. And the alternate hypothesis is the slope is not equal to 0, there's a relationship. You don't have to do the test at all because there's a p-value hiding right here. P-value of the slope is 0. Test statistic is gigantic, 12.6. So you are going to reject the null, which means there is evidence, this slope's not 0, there is evidence that the electricity production is related to wind velocity, which I guess is a good thing because that's the whole idea of those windmills, yeah? So that's it for problem number 5. Moving on to problem number 6. This is actually one of my favorite number 6s of all time. I think it's pretty funny. They have this problem where they ask this question to millions or hundreds of thousands of 12th grade students. They selected a sample of 9,600. And out of those 9,600, 28% got them right. So I just did a interval on my calculator. I got 26.82% to 29.18%. I am 99% sure that the actual proportion of all students who answered the problem correctly is somewhere between 26.82 and 29.18%. So the 28% that got it right is from the sample. This is now a confidence interval for the whole population. So first of all, I thought it was a little funny because it's not very good, huh? I didn't get too many right. Then they said, assume that the students who know the correct answer have a 100% chance of getting it right, and everyone else is just guessing. So like there's no logic to anything. And then it says, let K represent the proportion of all students who actually know the answer. So if you go back to the 28%, most of them, actually yes, most of them, did not know the answer, they just guessed. So now they're trying to figure out how that works out. So they asked me to do a tree diagram. Here's my tree diagram. K is the probability of them knowing the answer. 1 minus K is them not knowing the answer. If they do know their answer, they're going to get it right. So correct is 100% probability they get K, wrong is 0. If they don't know the right answer, they're still going to get it right 25% of the time, so they're just going to guess. So that becomes 0.25 times 1 minus K. And if they don't know the answer and they guess, they're going to guess wrong 75% of the time. The actual question was, based on the diagram, what's the probability, in terms of K, what's the probability that someone gets the answer right? So it's this plus this. So K plus 0.25 times 1 minus K. And you simplify, you get 0.75 K plus 0.25. And then it says, using the interval here in that answer, let's get an interval for how many people actually knew the answer. So that means this 0.75 K plus 0.25, that's how many got it right, is going to be between the 26.82 and the 29.18. We just solve it for K. So subtract the 0.25 from both sides, divide by 0.75. And what that means is the actual people who knew it right, who knew the answer was somewhere between 2.4% and 5.57%. The rest of the people are just guessing. Pretty crazy way to look at that, but pretty cool problem actually. Pretty cool number 6 problem, I think, just because it had some more reason to it, made a little bit more sense kind of in the real world. That's it for 5 and 6.